Hello and welcome to all the viewers. In this video, we will going to see a transient structural analysis of centrifugal pump base frame using ANSYS workbench. So this slide represents the learnings in this video. Very first, we will discuss about the small introduction to transient structural, then governing equations, as well as the different methods of transient dynamic analysis, and then we will move towards our actual problem definition of present video, and then we will go to our ANSYS learning part. So there we will discuss about how to apply loading boundary condition, how to perform modal analysis, transient structural analysis, and then at the last we will discuss how to extract the result and how to interpret that. So this slide represents the small introduction. When we talk about transient structural analysis, so it is nothing but used to find out the dynamic response of a structure under the action of any general time dependence load. Hence, it is also called as a time domain dynamic analysis. So in this case, the loading will be your time history and your response also you will going to get time history response. So in simple words, you will going to apply load versus time as an input and you will get output in form of response versus time. So it might be your displacement versus time, stresses versus time, velocity, accelerations. Okay. When we talk about transient simulation, it includes inertia, damping, as well as we can also include the non-linear effects. It is also known as a time history analysis or transient structural analysis. So you should not confuse with transient dynamic or transient structural. So both are the same. So as mentioned here, it includes non-linear effect. It means that if your model consists frictional contact or material or geometric non-linearity, you are able to analyze that effect with the help of transient structural simulation. So this is not the case when we talk about other dynamic simulations such as model as well as your response spectrum simulation. In that case, you will not going to capture or you are not able to capture the nonlinear effect. So this is what the advantage of in case of transient structural simulation. So that's why in most of the time when you have time domain response as well as when you have time loading, so basically here as we discussed load versus time loading, and also if you have some geometry or your frictional contact, in that case it is recommended that to use this transient structural simulation instead of other dynamic simulation. Now let's discuss about the governing equation of transient dynamic simulation. So it is nothing but your mx plus cx plus kx is equal to f of t. So as name suggests that this is what your nodal acceleration vector, this is your velocity vector, this is your displacement vector. So once you will satisfy your inertia which you will going to get with the help once you will apply loading, damping which you need to define, either it might be structural or material damping, then the stiffness which the model will going to consider with the help of your geometric as well as your material define. Once you will satisfy all these conditions, you will going to get the your time domain response for the applied time domain load. Now let's discuss about what are the different methods when we talk about transient dynamic simulations. So there are two methods. First one is your full method and other is nothing but your modal superposition method. So both have advantage as well as disadvantage. The prime advantages, or you can say the pitfalls, are mentioned over here. So first, when we talk about full method, it uses all types of non-linearity except mode loads types such as element load, tubular load, non-zero displacement, nodal forces, and also it is simple because it does not consider your modal simulation. Also, when we talk about full method, it is computationally more expensive than mode superposition method. This is because here first you need to perform model simulation, and based on your model responses it will going to calculate the your time domain responses. So there is a limitations in model mode shifts perspective, but here that is not the case. It will going to consider all your applied loading conditions, so that's why it is computationally more expensive. Now let's talk about model superposition method. So it is model analysis based method, hence does not consider non-linearity. So as discussed in previous slide, in case of other vibration simulations such as model analysis or response spectrum, it does not include nonlinear effect. But when we talk about transient structural with the full method, there you can consider the nonlinear effect. Does not accept non-zero displacement. First you need to solve model analysis and then transient. So basically it is whatever the simulations you will going to get, for that first you need to extract the mode shapes, and it is faster as well as less expensive than full method. Okay, so these are the two basic methods of transient structural simulation or transient dynamic simulations. Now let's discuss about the actual problem definition of our present video. So if you see here, we need to perform a dynamic shock analysis or dynamic transient structural simulation of centrifugal pump base frame, okay, for a given shock profile. So if you see here, this is nothing but the actual schematic of your centrifugal pump, and here we need to analyze for a shock profile which I will going to show you in the next slide. So this is what your geometry, this is the simplified geometry which we will going to consider for the simulation. So here we will not going to consider your centrifugal pump, so we will going to adjust this 350 kg mass and we will going to apply this using a point mass. Okay, you can see here, and we will going to connect with the mounting location similar to motor location. You can see here motor is 450 kg, so we will idealize this by using point mass and we will apply that, or we can connect that to the your mounting location. So here we will going to use the second method, that is mode superposition transient structural simulation. So this slide represents our shock loading profile. So as we know that we need to qualify this base frame for a transient structural simulation. So one of the loading condition when we talk about transient structural, there might be some sort of shock conditions. You will see when you will do some sort of testing, or when this equipment is subjected to sudden load which will withstand for a very short duration of time. So like if you see here, you will find only 30 millisecond is there the time duration, and within this time duration it is going to be extended up to, you can say, like 37.5 meter per second square. Okay, so right now you will see this horizontal axis represent the your time frame, while vertical axis represent the acceleration loading. So if you see, the profile is basically your acceleration versus time. So time came into picture, that is why it is called as a transient structural or transient dynamic simulation. It is also called as a shock analysis. Okay, so when we do the transient simulation, in that case you will find that this time duration might be much longer. Okay, but when there is a shock condition, you will find that your time duration will be few milliseconds. Okay, so that is the difference between your shock loading and general time dependent loading condition. So what we will do now, we will go to our ANSYS and there will perform this respective simulation. So as discussed earlier, there are two different methods to perform the transient simulation. First is your full method and second one is your modal superposition method. So right now we will going to use the mode superposition based transient dynamic simulations. Okay, for that first we will try to simulate the model analysis, and then second we will simulate the transient simulation. So now we are in our ANSYS workbench. So you just need to open your respective ANSYS workbench version, and then very first you will just need to drag and drop your model simulation, and once your model simulation is done, then you can drag your transient structural simulation, this one, over this. Before that, before simulating transient structural, you need to first simulate the model simulation. So as you know that we already covered a separate simulation of this base frame. So if you go to our channel page, there you will find model analysis of centrifugal base frame using ANSYS workbench. So there we explain a different fundamentals of model simulations, equations, assumptions, definition, what is the difference between free and model fixed simulation, then how to extract more shapes. So all this you will going to find on our graphs engineering video playlist. There you just find how to perform the model simulation. So right now we will going to use the same geometry and we will going to follow the same methodology. So I will suggest you should go first to perform this model simulation. So all your doubts will going to cover through this in-depth video. Like you will find that we explain what are the significance of participation factor, as well as you will find that we also concluded based on different mode shapes. So you just go through this video first and then you can perform your transient structural simulation. So now just double click over here. So you will find that same model we will going to use. Okay. Now I will not focus on how to create a model. You can see this is the first remote point which we created. This is the second remote point, and on this respective remote point we applied a weight of, you can say, like 350 kg and another weight of 450 kg. Okay, and this is what the moderate mesh which we use to perform the simulation. And then you can extract the different mode shapes. The maximum number of mode shapes you need to extract, like you need to capture the maximum number of mass participations. Okay, so at least 90% mass participation is okay for a present simulation. And then you can fix your foundation bolt location, or you can see here this, let's click on the faces. Okay, so we fix these four different bolt hole location. In actual, you will find that in most of the buildings this base frame is mounted on a concrete floor, on which you need to first apply here, right click, insert, see the compression only support. Okay, you need to apply a compression only support on this faces, and then you need to apply your translation fix on this respective point. So right now we are going with the worst case scenario. We are just fixing this 4 bolt hole location in all degrees of freedom, and for that we will try to simulate. Okay, so we are planning to do one more simulation for the anchor qualification. In that case we will explain in all depth all the aspects of how to apply boundary condition for a compression only support, how to simulate the anchor validation part using ANSYS. Okay, now let's try to simulate this. So now if you see, our model simulation is performed, and these are the different mode shapes. The first mode shape on the motor base, you can see, and this is the second mode shape, this is third, fourth. Let's see what is the global mode shape. Let's try to see some scale. Okay, and if you try to animate, you can see how it is deforming, or you can see how it is vibrating. Okay, so you just first go through the our model simulation, and there we explain all these mode shapes. And let's go inside the solution part, and here let's try to check how many. Okay, we extracted the 12 mode shapes. For that we extracted 95% of mass, x-axis, y-axis as well as j-axis. Okay, you need to further extract few more modes to get the furthermore in a j-axis simulation. Okay, so right now we will just continue with the 12 mode shapes. So now let's go to our transient simulation part. So I will further insist you just go through the model analysis simulation first. There you first explore, and then you can do this transient structural simulation. Okay. Now going to our here you can see this is what our loading profile, and let's try to edit the data. So what I will do, I will just copy, and I will go to simulation, and here we can we will going to put that under inside you will find the acceleration loads. Okay, there are you can even apply standard earth gravity rotational forces which are varying with respect to time. So these are the different loads which you can apply in a transient structural simulation. So right now let's apply acceleration, and you can either apply by vector or else you can apply by the components. So when we talk about shock profile, uh, you can see that this is y is nothing but your vertical axis, and we assume that this shock profile belongs to your vertical axis. So for that, what you need to do, you just need to paste over here. So whatever the loads we saw over there, you will find over here. So let's do Control C, and you can do here a Control V, and let's uncheck this X and Z. So what I'm doing, I want to apply only in a y-axis, which is the vertical one. So for that you can see the profile. Right now you can see this is what our the maximum, but here you can see the time frame is 1. So let's go to our loading condition. So if you see here, our shock is like only for a 30 milliseconds. So but what will happen, it will take some time to get the response of the structure. Suppose if you have maximum response is at in between 15 to 20 milliseconds, so it will take some time to get the high stress. That is called the, you can say, the rebound or response. So that we need to capture. So what we can do, let's go to analytics setting. Here let's extract up to 0.6. Okay, this is the end time. So now you can see the actual profile of us, and then you can define here a time step. So if you want to extract more and more responses, then I will suggest to decrease this. Okay, this is reasonably good to capture the response at discrete points along the shock profile. This is the first point. Another, you can define the damping. So basically let's define the 2% damping, 0.02. Okay, because there are few uncertainty which are not captured while doing the or simplification of FEM model. So in that case it is better you can consider less than 5%. Okay, now you have applied your acceleration, you have applied your shock profile, and then so it is like carrying this result, so no need to apply boundary condition. So let's try to simulate. So now if you see our simulation is performed, now let's extract the stresses as well as deformation. So let's extract the stress, equivalent stresses, and right click evaluate the result. So now you will find that a response is written on each and every steps. Okay, so if you click on the deformation, let's uncheck minimum average. So you will find there is various discrete points on which the response is recorded, right? So it is went up to 60. So now if you see the maximum deformation which is recorded at a point of 0.026, so basically 20 millisecond you can consider, and our maximum response is at like in between 15 to 20. Let's go to, so our maximum response is approximately, you can say 16.5 millisecond maximum load, and it took further few seconds to get the higher response. Okay, this is all about your deformation. Right click, retrieve this result, and let's talk about the stress. So make it true scale. Okay, let's define some 150 limit, and here you can see the maximum stress which is observed, which is something localized on a few nodes. And other than that, if you see the stress here, here, sorry, here, okay, somewhere here. So if you do further refinement, then it will going to further do the correct stress values. Okay, so this is like 60 to 100 megapascal. Few localized region is 100 megapascal, and the maximum is 233, which is over here on this location. So on the weld location, so you might need to strengthen this part to increase the steepness to reduce the stress values. So let's check the graph further. On the graph, so the similar responses were observed, as you will find the maximum is like 24 millisecond, and our maximum load is 16.5 milliseconds. So basically it took some time to get the response. So 24, so approximately 7.5 millisecond it took to get the higher response. Okay, now let's extract few probe results. If you want to extract stress on a single node or on this phase, apply. So let's check x-axis, or our axis is y-axis, evaluate. So if you want to do some probing of the result, you can do by this way. Okay, so you will basically going to get the stress versus time response what we discussed earlier. Okay, similarly, let's talk about equivalent stress probe. If you probe here, and you have the respective location XYZ, and also you can find out easily the time location. Now let's talk about deformation probe, and let's talk about the deformation. You can capture deformation on point, on vertex, on edge, on face, on bodies. So all these options are available. So let's extract on this edge, apply. Okay, and here you can apply XYZ. What? Let's have y-axis deformation. Evaluate the result. So now you can see you found this response. For this, here you will find the maximum deformation is somewhere here, which is 1.6. Okay, so like this time profile, you will going to get the response through this transient structural simulation. And let's talk about stress further. So you need to check thoroughly these parts, so which is having like 100. So right now what I feel that our yield stress is 250, so our structure is below 250 megapascal, so it means that we can say that it is satisfying the yield criteria. That's why the design is safe for the yield criteria. But if you want to put some factor of safety, accordingly you need to check. Okay, and where you find the highest stresses at that location, you need to increase the stiffness. So you can even cross check with the respective mode shape. Okay, and mode shape, mass participation factor, and then stress. So once you will strengthen your part, your mode shape will going to change, like your vibration will going to change in the directions. So accordingly you need to check the stress also. Stress will going to shift. So that is what the importance of model simulation, and then you can get the results similarly on the responses which you got from the natural frequency. On that responses you are applying the shock profile. Okay, so that's it guys. Let me know your comments, I'll be there to help you. So basically you will find the similar video which is we already uploaded few years before, but the problem like we observe from few viewers, they are facing a problem due to the background music. So at this present video we will not going to add any background music so that you can explore how to do this shock simulation for the centrifugal pump base frame. So let me know your comments, I'll be there to help you.